Hello, my name's Ed from SHARCNET, and today I'm going to present to you how to use the cloud to enable internet access to the HPC clusters. Now, traditionally, to use an HPC or high-performance computing cluster, you'll log in with SSH and submit the jobs through the command line. As computing resources become more and more available and more researchers want to use these high performance computing resources, not everybody has the technical expertise to log into the command line and submit jobs, or there's a bit of a ramp up in the learning curve. So there has been inquiries by people on how do you set up a web server, or how do you enable a point-and-click access to high-performance computing resources or to a cluster. And that's what we're going to cover today. And we're aiming towards somebody with enough technical know-how that they can set up a web server and set up the job submission so that other people can use it. So without further, what is a cluster? So the cluster is what you would typically log into, and that's what we'll be referring to, and the client is what you're logging in from. As you can see here, it's typically through SSH. And while you can access the nodes or the login nodes from the internet, as you do for file transfers, you do not typically access the work nodes from the internet. The SSH will facilitate your secure connections over unsecured networks using the client-server architecture. And that's what we're going to be utilizing today in order to submit our jobs. Now, you are familiar with the application of SSH for remote login, but it also has file copies and the ability to submit remote commands without logging in. Traditionally, you can't use the World Wide Web on the cluster. You can use the World Wide Web on a cloud. What we're going to do is we're going to spin up a cloud instance and we're going to load up a web server. And in order to facilitate accessing the cluster, we will use SSH to go from the cloud to the cluster. So what we're showing here is the client will, after it's set up, access the cloud resources that we've set up from their client and using SSH fuse and SSH itself to give commands or to give batch commands to the cluster, and then read that input back, or the resulting output, back, and send it back to the client. Now this involves, we're going to use what's called a LAMP stack in order to do this. And a LAMP stack is stands for a Linux, Apache, MySQL, PHP solution for deploying a web server. These are also known as full stack solutions, and they don't always necessarily have the same combination of Linux, Apache, so on and so forth. You could use a different web server or a different database, or you could do it from Windows. It's just that LAMP is one of the more popular acronyms, and everything we're using there is free software, open source, which is why we just selected it. Now I'm going to briefly go through some of the technologies that we'll use and give a quick description over what they are. And the goal of this is just to give you a starting point for when you want to deploy your own. So the Linux is the operating system, which most people are familiar with. We're already running it on the clusters. We'll be using Debian today, simply for my own familiarity. Or you can use CentOS or Ubuntu. It's also. For the web server, we'll be using Apache because it's open source, and there's quite a bit of resources on the internet for it. We'll be using MySQL, or it's actually going to be Maria database, I do believe it's called. And we'll be doing our server-side scripting with PHP. You can also do your server-side scripting with Node or Java or in C if you like. PHP is just very well integrated with the whole stack. Some of the other technologies we're going to be using today, I'm going to briefly mention here. We're not necessarily going to go into too much detail on how they're all used, but you do use a lot of technologies in your tool chain to get everything up and running. OpenStack is going to be the cloud software that we'll be using today. It's what's used to launch the instance. Let's Encrypt is a free SSL certificate site that we'll be using, and that will allow us to ensure that our connections are secured using encryption. Java is a technology that's actually what I deployed on Graham is just going to be running a Java program that we get started from our web interface. SSH, of course, is highly represented here because we'll be using that to do our communications. JavaScript, something it's good to know for programming the client side of the web app. And SSHFS, which is the SSH file system that we'll be using to connect all the different services together. Going into a bit more detail and just a bit of a preliminary on what we'll be doing today, the second half of this presentation, I'm actually going to open up the terminal. We're just going to go through and load the web server from scratch. We'll start with an empty cloud instance and load the LAMP stack from there. And that way you can actually see it taking place, and it's a lot easier to understand the commands in the order that they come in if you just see it happening. But in order to do that, I want to go through a couple of the more important ones that we'll be using today, and that would be Apache. It is the second most popular open source web server, for some reason recently overtaken by Microsoft's web server. However, we'll still be using it as it works quite well on Linux. To install it, we'll be using apt install Apache 2, quite straightforward. To start, stop, and restart it will be from the command line. It'll be service Apache 2, and then one of the commands. We'll also be using the add remove modules that come with the Apache distribution, and that's the A2 enable mod, EN-MOD, and disable mod, DIS-MOD. And these are the things that start and stop different Apache services, such as SSL or encryption. We will be installing MySQL, which now is MariaDB on the Debian distribution, because it's such a popular software package. We won't actually be using it today, but it is just a standard installation that goes with most LAMP stacks or full stack distributions. It's a very popular SQL server. There's a lot of information on the web for that. That's part of the reason why we choose some of these solutions is on the documentation. Again, what's the install? We'll apt install MySQL server. A lot of the times you'll forget the server part and go MySQL and wonder why it won't. It's just -server. The same as Apache, it's service MySQL-D, start, stop, restart to get the server up and running. And we'll also be running a command called MySQL secure installation, which just automatically cleans up a lot of the MySQL default installation for security purposes. I would like to cover at this point CRON Jobs. What you can do with a CRON job is to schedule automated tasks to run on your server. And CRON Jobs are one way of making sure that security updates are done. In a bit, I'll be showing you another way to make sure that security updates are done, but we'll just cover CRON for now. CRON is a time-based job scheduler that is included by default with Linux. And that means that it will run a job once every minute or once every hour or so on and so forth as you specify. We use it to improve security by doing things automatically, so you don't have to remember to do it. CRON is controlled by things known as cron tables or cron tabs. You'll hear that term thrown around a lot. And it's located in the var spool cron tabs directory. In order to start your own cron or cron job, or to schedule your cron job, you're going to use the command crontab -e to create or edit a cron tab or cron table. The cron table format you'll see is this. You'll go hours, minutes, hours, days, months, and then days of the week. And you'll see when putting in the cron tab, so you'll cron tab what you want, the number of minutes. A star means the star is the wild card, sorry, and then the command to execute. Moving on from that is the SSH rules, or the SSH command line. Now the vanilla SSH command line is just SSH with your username and your server. And most people are familiar with that. The command for sending a command to the server to bypass logging in, you'll SSH the same your username at the server, and then you'll put your command in, and then the arguments for your command after that. And that'll just send the command to the server. To execute the SSH as another user, you're going to be seeing me do that, is we'll use sudo. And sudo-u with a username means you'll be running a command on the command line as a different user. And this is important for when we do things as the Apache server, because the Apache server doesn't actually let you log in as its user. And that's for security reasons. So we have to do all of its stuff through sudo. We're also going to use SSHFS to mount a drive, and that would be the user, your username, at the remote server's name, so user at server, the remote server's directory, and then the local directory that you want to mount it on. To unmount, which we won't be doing today, but it's important to know, you use fusermount -u and then the local directory's name. You have to keep in mind you'll have to set it up so that these mount every time you reboot the server, because when a power down happens, it's going to unmount things. But that's neither here nor there. The remote copy, the last SSH command, is SCP for secure copy. And you'll be using user at the origin server and the origin directory to the user at the destination server and the destination directory. We'll also be using the flag -3 to turn off host-to-host transfers, and that's just because sometimes it can get annoying with SSH keys that weren't installed. So just to review the tool chain that we're going to be using today and how we're going to set up our program. So we're going to set up a program that will simply submit a job to Graham and take back the job ID. And that means that the user will submit their job. They'll choose a file. JavaScript will handle the file uploading to the LAMP stack. PHP will save the file and call the command line, which will do the remote command through SSH to the SHARCNET cloud or SHARCNET cluster. The SHARCNET cluster will then execute the Java command and then use SSHFS to copy the files back. So what we're going to do now for the second half, well, now that I've just simply reviewed the basic background, is we're going to load up the command line. Well, we're going to launch a cloud instance, and then we'll load up the command line and we'll actually set up a LAMP stack server. So we're going to go to the dashboard of the cloud and log in. Now I've already launched the server I'm going to use, basically because it takes a minute or two for everything to get set up and we'd rather not wait. So what we have here is the cloud dashboard. We're going to go to instances, and over in launch instance button over here on the right hand side, we're going to click on that. You'll notice demo is already running. We'll choose an instance name. In this case, we'll just call it demo2. You want to choose your source. Remember to set the volume size. If you don't, it doesn't launch properly. I typically delete the volume upon instance deletion. That means when you shut down the instance, it'll destroy the drive as well. Oh, sorry, delete the instance. It'll delete the drive as well, not just shut down. The flavor we'll be using is Debian. CentOS is also a typical choice, and Ubuntu is a Debian flavor. we are going to launch as a persistent versus ephemeral, which is because we're going to be using this as a more up and running service. Another thing you want to check is under your key pair. You have to load your key pair up. You can import or create a key pair. And this is so that when you log into the server, you're not using a password, you're using an SSH key. And the last thing you want to double check is the security groups. Now, I have already set up the security groups so that, there it is. You'll notice that port 80 and port 443 are already enabled. And that's because those are the web ports. So 80 is going to be your HTTP port, and 443 is going to be your HTTPS port for secure web communication. And with that, we're going to click Launch Instance. And there the instance is launching. After that is done, we'll select Associate Floating IP and set up an IP address so that we can connect it to the web outside. But we have already done that with 192, sorry, this would be the IP address we're using. Now, as a side note, I'd like to point out that I have already associated this IP address with a name. I've used Google's domain. If you send in a ticket, we can give you a subdomain from SHARCNet. And the reason I have done this is so that when I use the Let's Encrypt service for the free SSL certificates, they do it with domain names. They won't use IP addresses simply because then there's a lookup and there's a real person behind it, as opposed to an IP address, which can cause security problems for them. So you'll notice when I use it's frar.ca when I use it, and that's just already been associated to the 199.241.164.95 IP address that you see here. So the first thing is we'll just SSH. I'll just go to the actual address that I just mentioned just to show you. By default, it's Debian@. And typically the default login name is from whatever flavor it is. I will, however, have used a config file so that all of that is already set up here, and I'll just SSH in the cloud from now on. But that's just a forward to 199. And I'm mentioning that so you're not confused when I just do SSH cloud. So the first thing we want to do, now that we're in here, is we're going to switch over to root to make it easier for us to install some programs. We're also going to eventually disable root remote access so that you would have to log in as Debian and then as root. The first thing you want to do is apt update to update your packages. They are up to date on this because I did it previously, because it does take a little bit of time to do that. And we'll do apt upgrade. And this is the very first thing you want to do whenever you launch a new instance. That's just to make sure that all of your security updates are up to date. And we are going to apt install man pages, simply because they're handy to have. Do we want to continue? Yes. And it takes a little bit of time, a little bit of progress bar there. For those who are familiar with apt-get, I'm using apt as the newer version, which just gives you a bit, tells you how far along you are. So now that we've got the manual pages in, we are going to do a little bit of securing of the SSH configuration. So we'll vim into etc//ssh/sshd. And just as an aside, I am going to post all of these commands on our wiki page so that you can go back and look at them again without going through the video. And a couple of things we want to change here. First thing we want to change is password authentication. And the reason what we're going to do there is we're going to disable password authentication to say that you must log in you must log in with an SSH key as opposed to passwords. And that's just so that it's just to prevent you from doing something like setting up a user with a poor password and then getting hacked. The other thing we're going to do is we're going to prevent root logins. And that means you have to log in as someone else and then sudo over to root so that remote root commands won't work. Just for security purposes again. And that's the majority of what we're going to be doing here today, is just setting things up just to get some basic security up to date. We will write and quit, and after we've changed the SSH settings, we are going to reload SSH so that they take effect. We are now going to set up the other. So the one way is of setting up automated updates is CRONTAB. Another way is installing a package called unattended upgrades. And it's fairly straightforward as apt install. And what this will do is it will make sure that all of your basic security upgrades have been performed or are performed on a regular basis. In order to get it up and running, we'll put in the following command. And we just simply say, yes, applying updates on a frequent basis, telling you why we're doing this, the security reasons, and the distribution, the packages we want to include in this. And now, just to test it, we'll show you what it does by using running the command, and with -D for the debug flag. And that just shows you what happens when it does its updates. So the next step after that, we've done some basic SSH securing. We're going to install the MySQL server. Again, we're not actually going to use the MySQL server today, but you typically include it as part of your web solution stack. So apt install MySQL server. There we go. So the MySQL secure installation is a command we're going to run, and it's just going to do the steps for us to make sure that certain things are done. For example, there is no password by default for the SQL, so we will set a password. Remove anonymous users, yes. These are things just to make sure that your SQL service is up and running, that you'd like to disable after the fact. Disallow root login remotely, yes. You should just set up a user account that does restricted to certain tables. Remove test database, yes. And reload the previous tables means enable what we just did. And that's it for securing MySQL. To access MySQL, of course, just type it, and we'll see that in this case, it's the MariaDB server. And we will exit. Lost my mouse pointer. There we go. The next thing we're going to do is install Apache, and this is the root of what we're doing. And the command itself, again, is simple: apt install Apache 2, because it is Apache 2. Yes, we want to install it. And these are they're not huge installs, but they do take a little bit of time. And after we've done that, I'm going to show you that it's up and running on your IP address. And then we'll do some basic things to secure Apache. We're not going to go through all of the possible things to secure it, just for time constraints, but we'll do the basic things that you need. You can do things like remove directory indexing, etc., which will further secure it. So now the command is service Apache 2 start, and that will start the server. And just to show you, I'm just going to browse to the IP address to show you that it is up and running. Go back to here, and it was 199, and there it is. So that's the basic page. That's the default page. Some basic information that you want to know about running your Apache or where different things are. /var/www is the root Apache directory, and in there is HTML, and this is where your web pages are. So index.html is the default web page that we just saw. You also have the access logs and the error logs are under /var log/Apache2, and those are where you'll see what web pages have accessed and any errors that your server has thrown. So we just look at access. Should be one on there because we just looked at it. Keep in mind that if you use CentOS, these may be in a different location. This is currently the Debian distribution and where things are. So there is now a user under here as well called www.data, and it's set up in the Apache config file, which is located under /etc/Apache2, and the config hat. So if you need to do some basic configurations, you can do it in here. And we'll be doing a couple of changes, but you'll see things like there's also environment variables under this directory, which is shows you things like the www.data user and the www.data group if you want to change who you are. We're just going to leave it the default. There's no reason to change it. So the first thing we're going to do to secure Apache is we're going to set up SSL certificates. So secure, so you can go to the HTTPS address instead of the HTTP. And so the first command we're going to use is the A2 Apache 2 enable module SSL. Note it's telling us we need to restart. System control is another way of using it instead of service Apache 2 restart. And in case you're wondering, I'm reading that there. But we are also going to A2 and site, so Apache 2 enable site default SSL configuration, and that'll just do some setup for us, and we'll restart. So now we'll browse back to take a look at our website. Still there. However, now if you go HTTPS to the address, we'll get this warning saying your connection is not private. And what that's saying is, though they're sending though the server is encrypting it, the SSL certificates haven't been set up. You could set up a self-signed certificate to do the encryption. However, we're going to use Let's Encrypt because you'll still get this warning if you use a self-signed certificate, and some people might be put off by it. You can proceed. It tells you that you are not secure. And this is something that everybody should know in general for all websites. On Chrome in particular, you can look to see why you're not secure and get information for it. So if ever you're at a website and this is lit up as not secure, it means the encryption isn't set up correctly. But we're going to go do that now. We'll note, I'm just going to go to frar.ca. As I mentioned earlier, it's the same site. It's just pointing to that IP address, but we've set up so we can use a service known as Let's Encrypt. Let's Encrypt is the free SSL certificate service. To set it up, we have to download their source from GitHub and install it. So the first thing we need to do is apt -y for the automatic yes, install Git. So we're going to install Git. I'm going to copy and paste this address over because it's fairly long. Again, you'll find it in the wiki pages. So we're going to clone, paste. So clone from the GitHub repository for Let's Encrypt, and we're going to put it in /opt Let's Encrypt. It's the instructions that they gave me. It's going to retrieve stuff. So there we go. We've got that there. We're going to go into that directory /opt Let's Encrypt. These are the files we just downloaded, and what we care about is certbot auto. Certbot auto is going to just set up everything for Apache. If you use a different web server such as Tomcat or Glassfish, you have to set up your certificate slightly differently. We won't get into that today because we're not using those servers, but it's good to be aware of that. And it's installer, not interaller. So this is going to install a bunch of packages that take a little bit of time to get up and running. But some of the stuff we're going to need to know in a minute is where is the web root, that is /var www.html. And we also need to know our domain name, which is the FRAR that I provided up there. After this, we're going to set up some basic user password verification. And this is going to be the Apache supported user and password for logging in, because you don't want just anybody coming in and submitting jobs to your account. We're also going to install PHP, and that is a very common server-side scripting language. And that's just because I've used it for my program. And after that, we'll move some SSH keys around, and we're going to set up the www data user. Again, I'm just filling dead air in here while the package installs. Oh, now it's installing Python. What we didn't do is set up CGI scripting, and that's if you want to run things, a C program or some sort of scripting, other server-side scripting language that's not PHP, such as Node, etc. We just skipped that part. There we go. Python usually takes a little bit. Oh, still can't spell installer, can I? Installer, Apache. We're going to run that again, but you should note that because we've already set up Python, it won't take very long. So we're going to insert an email address. I suggest you use a real one because they will send you notifications that your certificate has timed out. Every 3 months they invalidate your certificate and you have to update it. So we give them an email address. We agree to their terms of service found on their website. Would you be willing to share your email? No. Names found on, so this is the domain name, and this is why I mentioned that earlier, and that's the one I registered with Google. Input the web root /var www/html. So what this will do is it's going to, we're running this as root, so it's got the permissions. It's going to basically put in a challenge page into your web root, which they will then browse to make sure that you are who you say you are. And we pass it because we are. It has enabled the SSL services. We already did that. And no, we don't want to redirect. I prefer to do that on my own. So now we will take a look. The FRAR.ca still works. And now if we go to the secure site, we don't get the warning. And you'll notice that our little secure icon up here is green. And that just enables encryption. And you should run all of your websites through HTTPS. And that enables encryption and makes it harder to steal your information. Next step, add basic user password verification. So we are going to go to /var www. Now I made the mistake of doing this before I did Let's Encrypt last time, If you do that, then the Let's Encrypt needs the username and password and won't work. So you have to do this after setting up Let's Encrypt. We are going to make directory password directory. We are going to run ht password command. Now what this is doing, this will create a username password combination that we'll use to log into the websites. The location of the password file we want, and the username. We'll just call ourselves user. So we've added a password for user called user. So if we look at that file, it's just username with an encrypted password. Now we have to set up Apache to require passwords. So we will go in and modify the configuration file directly. There we go. And it is apache2.configure. We will go down, we'll put this into the var www directory. I'm just scrolling down here. We're going to change a couple of things. First things we'll change is we are going to require valid user. We are going to authentication type basic, authentication name, files, and this is the location that you put your password file. So wherever you put it, we put it in var pa passwords, and right input. I just go double check something that is what I actually called it. Yep. And we have to restart Apache to make this take effect. There we go. Now we will browse to our site again, and hopefully it will be password required. So now we require a username and password to log into our site. We'll just save it, and there we go. If we refresh the page, we don't have to put it in again until we close the browser. And that's just to stop people from just walking up to your website. We are now going to install PHP. And that, like I said, again, is the server-side scripting language. This takes a little bit of time to install itself. Oop, didn't actually do it. Copy, paste. There we go. -y means it'll just say yes automatically. And then after this, the last thing we're going to do is we're going to give www.data an SSH key and ownership of its home directory. Its home directory is /var www, and that will just allow it to manipulate its directory. It's just good practice, I suppose. The SSH key, however, we're giving it is so that it can send commands to the Graham server. We'll create an SSH key for the Apache server, and then we'll copy that into our Graham authorized keys file. Okay, so we've set up PHP. This is a good test to make sure that PHP is installed correctly. Is we are just going to create a basic PHP web page. Paste. So what this is, again, I didn't copy it properly. So it's echoing. We're just going PHP info into that web page, test.php. It never likes the colons that come out of Word. So we're just going to fix those. Now we will go browse to that page to make sure that PHP is running. And it is our website /test.php. And this is just the PHP information. And that's the page we just created. So next step, give www.data an SSH key and ownership of its home directory. So its home directory is var www. We are going to chmod, change the permissions for the www HTML directory so that it has, what we're looking for here is read write. Sorry, it should be 774. And the reason we're doing this is we are going to give the Debian user, or login user, rights to upload files to that. And that's because your Apache user doesn't actually have a login. chown changes the ownership. So we want www.data user and www.data group to make it recursive into there. So now if we take a look at it, the HTML directory is owned by www.data. The next step, we'll make an SSH directory. We are going to do this as the Apache. So sudo -u www.data, which is the Apache username, make directory.sh. So now there's an SSH directory owned by www.data. And we are going to make a keygen, or we're going to use keygen to make a public-private key pair for the Apache user. Again, we have to do this as the Apache user. So sudo -u www.data sh keygen to create the key. Now I'm going to give it a comment of www.data, and that's just so I can find it in authorized key files later on. And that's the comment at the end of the key. Generating key pair. Yes, we'll put it in the default spot. For now, we are not going to put a passphrase on it. You could, but then you have to set up your bash scripts so that you use the keychain to get into it. So now there is a key pair for ID, or for the www data for your Apache. What we need to do here, however, is get it over to Graham. So the first thing we're going to do is we're going to copy the public key into the Debian user home directory. .sh public key / audio. There we go. Public, not the private key. Make sure you do the public key, and we are going to put that in home / Debian, and you'll see why in a second. I am also going to add Debian to the user group of www.data, and that's with user mod -add group www.data, the group name, and then the username. And that is so that the Debian user has permissions to upload web files. So exit as Debian, go directory home, make sure the file's there. ID RSA pub, that's the www.data public key. You'll exit. Now, I'm just going to go into Graham real quick and make sure I've deleted previous keys from my tests. So .sh. Now, in here, you've got your authorized keys file. In there, you'll note that I've got www.data from previous tests. It's not going to be the same one, so I'm just going to copy my public key back over. So cp ID RSA to authorized keys. And that just empties it out. So what we need to do is we need to copy the public key. So we're going to use SCP at this point. -3 prevents host-to-host copying, so that it uses my laptop here to do the copying. Copies it from the cloud to me, and from me to the RAM, because I don't have SSH keys enabled everywhere. Cloud ID RSA pub. And we want to go to Graham, and we're just going to put in the Graham root directory for now. Did not copy. I always do that. Or we can just do it in 2 steps. SCP. You know what I did? Ha. it is owned by root. So I can't copy it over. There it is. And we will copy that file to Graham. So what we did in those flurry of commands there was we created a public-private key for www data. We copied it to the Debian root directory, changed its permissions so that the Debian user is allowed to transfer it over to Graham. And basically all we're doing is creating a public key for the Apache server that we set up on the cloud that will allow us to do SSHFS in a minute. But first we need to add the key, so we're going to cat ID, RSA pub. We're going to use a double piping to which will append it instead of overwrite my SSH authorized key files. We will go in to make sure we haven't screwed anything up, and you'll notice that now www data has got its public key as well. So now our Apache can set up an SSHFS, which is what we're going to do next. So we'll call directory into here, /var www, not 4 but 3. We will make a directory called linked cloud. Oh, my bad. Let's change it to root first. We are going to make the directory as linked cloud, but we're going to do it as Apache. So sudo -u www data make directory linked cloud. And this is going to be the local directory, which is going to be mounted, which is going to mount our Graham directory. I have already done the Graham setup. It's already over there. We can show you that in a moment. But we need to install SSHFS. So install SSHFS, which stands for SSH file system, which means it's going to be able to mount a remote directory using SSH locally. I do believe our YouTube channel has a specific instruction video for doing that. Nope, that was pretty quick. The command, we've already made the directory we want locally here, linked cloud. Make sure I spell it correctly. And the command is a little long, and I'm going to copy and paste it so I don't get it wrong. We have to do this. Again, we're going to do it as the we will do this as sudo u www data. So we're mounting it as the Apache user. The command sshfs. My username @graham.sharcnet.ca. The remote directory is called linked cloud. Linked cloud. I'm supposed to call mine here linked Graham. So we're going to go fix that. We called that linked cloud by mistake. The one on the remote directory is called linked cloud. This one we want to call it linked Graham. So sudo su www data make directory linked Graham. You'll note that these are made as www data. And that one, force it, and put the command back in. There. Oop. Yes, we are accepting the key because it's a new key. Oh, what did it do? Well, we are a little short on time to debug that. Doing that. Well, that seems to have worked. I don't know why it was saying connection reset by peer. But okay, so we use sudo -u www data. Because it's a mounted directory, even as root, we can't look into it. It has to be looked into by the user that created it. And if you go ls linked gram, those are the files there. And those are the files on the gram cluster. So the last thing we need to do is set up the web app. Now, conveniently, I've got it set up on my laptop. And as everything that is set up there, so what it will do is connect using using what we just set up to connect to Gram. So I'm just going to download the web app onto here. Call directory HTML. I've got the web app saved on our local GitHub, and that will allow you to go look at it if you like to see how it's done. So we'll just download the web app at wget my archive. So there it is. We'll extract it. We want to name it something reasonable, so we will move it to CSV, just web app, we'll call it. So there, now we've got a web app on there. I've got some initialization variables I set up, depending on where it's running. So this is the location of the directories I just made, which are linked with Gram, and the user. Now, if we browse to there, we're here, we can go to CSV web app. And what this allows us to do is select files and upload them to Gram. Now, I do apologize that it is for some reason not submitting the jobs correctly right now, and that would be my coding. So we will, however, show you from my laptop. Now, of course, you can do all this from your laptop, which I've done. I'm running Apache locally and have connected with Win SSHFS to do the exact same thing. So what you can do is you can choose a file and upload it to Gram and submit it using PHP. So it takes a little bit to do the sbatch command, and it's submitted with that job ID. We can use PHP to look at current pending jobs, and we can use PHP to download the completed file. So the pending job is done. Now, as a note, for those of you familiar with web programming, Because it's not active, we have to probe the server once in a while to look at these things. And if we were to look at the PHP file, or sorry, not the PHP file, the JavaScript file, you'll notice it's on a timer. And every several seconds, we just look to see if the job is done, because it's not active. And the last thing I would like to point out to you, because I kind of skipped that part when we were demoing, is I want to log into Graham and show you what I actually just connected to, because we skipped this part for time purposes. So in my project directory, I have a linked cloud directory, and that's the name I gave it wrongly earlier. And in there, these are files. Input is the file that I just uploaded to the server. You'll note, if you want to look at your slurm, this slurm command, it's not the, this slurm output, it's not the output. Because we didn't specify where the file is, it's doing it from root. And that's why my root directory is, my home directory is polluted with slurm.out files. So, but in short, what we just did today was we deployed a LAMP stack, a Apache server, a MySQL server, Linux cloud, and a PHP scripting language in order to access Graham through SSHFS and SCP. The goal that I was trying to get to today is to show you how to deploy it and how to secure it. What we really didn't have time for was the actual programming behind it and how to do the PHP. Those files are available on the GitHub repository, and I'll put a link on our wiki. Thank you.